Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the A3 webinar series. Thanks for joining us for today's webinar, Unlock Value Stream Productivity with Robotic Cutting. My name is Clarissa Schwendeman, and I'm the Director of Marketing for the Association for Advancing Automation. I'll be serving as your moderator today. Attendees viewing this webinar are in listen-only mode, which means that you are muted. If you have questions during the webinar, please submit them in the questions panel at the right of your screen. We will try to address as many questions as we can at the end of the presentation. And if your question is not addressed during the webinar, the Robot Master team will respond via email. This webinar is being recorded, and a link to the recording will be emailed to you in the next 24 hours. This webinar series has been brought to you by the Association for Advancing Automation, also known as A3. A3 is the leading automation trade association in the world for robotics, vision and imaging, motion control and motors, and the industrial artificial intelligence technologies. We are your hub for all your automation resources, products, partners, new applications, trainings, and information on the latest technologies and innovations. You can visit automate.org to learn more. I'd now like to thank our exclusive sponsor of today's webinar. Robot Master is a Hypertherm brand, and it's an offline programming software for robots that helps manufacturers maximize productivity on production runs of all sizes. Robot Master makes programming parts of any complexity quick and easy as a result of its integrated CAD/CAM functionality. This intuitive and powerful solution is designed with process experts in mind, reducing the need for programmers and robotic expertise. Thanks to Robot Master for your sponsorship today. I'd now like to introduce our panelists from Hypertherm Associates. We have Chris Rich, who's the Director of Marketing for the Heavy Industrial Hypertherm Plasma business, who is joined by Patrick Celli, the Robotic Software Sales Manager for the Robot Master brand. Welcome, gentlemen. Nice to see you. And Chris, I'll now hand the floor over to you.
Great. Thanks a lot, Clarissa. Again, I'm Chris Rich. I'm the Marketing and Product Management Director for Hypertherm Heavy Industrial Business. And we're part of Hypertherm Associates. Just to give you an idea, kind of a little bit about our company. And my colleague Patrick represents Robot Master, part of the software group of Hypertherm Associates. Hypertherm has actually got kind of a neat story. It's the quintessential business success story. Literally started in a garage 50 years ago, over 50 years ago, and now has grown to be the global leader in industrial plasma cutting systems, and now one of the largest global industrial cutting solution companies in the world. You can see there to the left a little bit about our brand lineup. We have solutions in plasma, water jet, software and control systems, and also laser consumables. And one of the unique factors about the company, and frankly, it's part of why I joined, is that we're 100% associate owned. And I have truly found that this drives an ownership mindset. It engages our associates to focus on solving customer problems with innovative technology and solutions. So anyway, thanks to everybody for attending this webinar, and we're looking forward to your questions. So I'll assume real quickly that you kind of know a little bit about what we're going to talk about. We're going to quickly go over some of the trends in the industry. We'll talk a bit about plasma for those that don't know much about it, but we specifically want to focus on how robotics combined with plasma can help your business. We'll give you some case studies about what we've seen, some ideas on what to look for technology enablers, and how to get started with this. We'll also go through some case studies and have a bit of time at the end for some question and answers. So please send those in via the chat, break in, and we're happy to talk to you about it. So next slide is, I'm going to assume that nothing on here is going to be a shock to anybody attending. I don't want to be overly dramatic, but personally, certainly in my career, this is the most unprecedented time in the fabrication industry. Price inflation and frankly, material price swings have been completely crazy. We've had unstable supply chains, Customers' demands for delivery and quality have certainly not gone down. They've continued to rise. And what we hear more and more is the concept of a labor shortage. Not just the fact that you can't fill your open spots, but the skilled labor market is unprecedented in terms of its inability to fill. And last year, the American Welding Society estimated that there's going to be a shortage of 400,000 or more welders in the industry. It's just unprecedented. So Hypertherm constantly talks to our customers. We work through channel partners in the industry. We talk directly to end users through our strategic accounts and others and product development. And the needs in general have been pretty consistent over time, but there's really been some emerging new ones over the last several years. The top 5 needs that we consistently hear from our fabrication customers are this strong desire to have weld-ready parts the first time. Kind of the idea of the past of more craftsmanship, a lot of hand operations to get that part ready for welding is going away. People want to see that it's cut to print the first time. Part of that is wanting to reduce the amount of skilled labor requirement. It's not only expensive, but you're keeping the people that you need to do the hard parts involved in more menial tasks. Especially with the digitization of industry, there's a huge desire for productivity solutions as well. Connecting into Industry 4.0 enabled systems, having an IIoT solution so you can see your process and find areas that you can improve it. And then definitely in the last 5 years, we've seen this explosion of applications for specialty shapes and materials. Hypertherm cut its chops on big plate, 2-dimensional plate cutting. But the desire that we've seen from channel partners and customers for these specialty applications is radically increasing. And there's always a desire for better worker safety areas. So I'll assume that some of you know a bit about plasma, but for those that don't, I'll give you just kind of a quick history. I'm not going to go into the technology. It's super. I'm a engineer at heart, so I'd love to talk about that. But plasma has been wildly successful for over the last 50 years, and it's really displaced mechanical cutting and oxy-fuel cutting in almost every application. And that's a lot because of the versatility of plasma. Especially compared to some of the competing technologies, there's relatively low acquisition costs and extremely fast cutting speeds. And this is anywhere from sheet gauge metals all the way up through 3-inch mild steel or very thick stainless. It also doesn't really matter as long as that material is electrically conductive. Plasma can cut it as opposed to some of the other technologies out there. It doesn't care if it's rusted or painted or expanded. And the tolerance is when you cut it. The old days of kind of looking like it, you gouged it out with a chisel. Today's plasma provides great tolerance capability, great angularity, and it really isn't very sensitive to the thickness or thickness variation of the base material. And that's led moving from just plate material to these other specialty applications, beveling, using it in structural steel, being able to cut up skeletons, hand usage, pipe and tube, putting in chamfers and weld prep on. So plasma has been really shown to be versatile and stick into lots of different applications. Now, all that said, is we actually don't see that big adoption on plasma for robotic applications. So of course, we wonder why and where might we be able to help industry. This next slide I'm going to show you kind of illustrates what we think the big case is. And I've used this picture over and over again. This came from a customer visit that I did last summer in North Carolina with a large fabricator. This is a high-end manufacturer, very expensive materials, very specialized applications. Yet when we looked at their fabrication process, it was a complete dichotomy. They had pressure vessel heads that were worth a lot of money, very difficult to make, Yet they spent time laying out, and maybe this looks like your shop, laying out everything by hand. Literally, this the picture is the quality control supervisor with the guy that did the layout in the background. And they're using 2 levels to mark a top dead center, get radial axes, and then identify where they would cut through for features, whether that's access doors, nozzles, whatever, all different kind of cuts. And even projecting those features on that dome was completely done by hand. And because of the criticality of this, they're using welders to do this. They're not welding, they're spending all their time doing the layout. That process almost took a shift plus quality control. And then once they cut it, that's a very short amount of time that's in there. But the cuts weren't good. There was a lot of secondary operations coming in with grinders, trying to fix angles, fix bobbles. That's going to be naturally part of a manual process. And really what this ends up in is you're consuming a shift or a shift and a half, and you're still not getting great results. A lot of extra work before and after the cutting process. And we see this in a lot of industries. That isn't just that specific manufacturer. If you look kind of in this value stream, the cutting process is only one thing that's affected. That layout and changeover, the amount of time spent beveling, just purely the amount of money that people are spending using filler material when they're welding to try to correct issues is a huge waste. We see this across industries, whether you're talking industrial vessels, heavy machinery, structural steel, automotive, and in shipyards, and there's a lot of others, that the product that they're creating isn't necessarily matched by the manual processes that they're using to create it. So at this point, we want to just kind of put up a really quick, fun poll, just a couple of questions. And you should see a pop-up screen that's going to come up. Clarissa will drive that. And we're asking, have you actually seen that in your business? And have you ever thought about automating those tasks? And this is just a simple yes and no. And we'll talk a little bit later about some of the whys and how might you get started. So we'll let that run a little bit, and I'll let Clarissa know when we get some answers. All right, sounds like we maybe have our votes in. Yeah, Clarissa, if you could pop that up.
Chris, are you able to see the poll results?
I don't see it just on my screens, but maybe somebody else can since I'm sharing.
Sure, yeah. So we have 72% of people vote yes, that they've looked at automating fabrication tasks in the past, and 28% of people said no.
Great, and that sounds like very similar when we talk to other companies. There's this huge desire to automate, and now the question is how, especially on some of these areas where there aren't great solutions out there yet. And the real question is, how do we get started? So again, we ask ourselves the same thing. Why hasn't, and we care specifically about industrial cutting. That's kind of our focus. And when we look at the whys and why is it hard, there's kind of 4 big areas that we see. One is the programming tools and the software to control. Frankly, they haven't been designed with the idea of cutting around it. Patrick will talk about this a little bit later. Certainly welding and polishing and grinding, all that has been out there. But those tools aren't necessarily there for cutting. We also find that the people that do robotic integration tend to be very different than those application specialists that understand something like cutting. And marrying those two is not always easy. Likewise, we are working with certainly the big four robotic manufacturers, and Robot Master works with many manufacturers, yet those controllers don't necessarily have plasma modules built in. You can, when you bring the controller up, you can easily find a module for welding or polishing, yet cutting isn't there. And then lastly is because the tools aren't there, every application tends to be very custom. There isn't kind of a standard cell design that's set up for a cutting cell. So just to kind of lead into where we're going next, you know, in the work that we've done and where we've been able to implement this, we certainly want to talk about the complete solution and what should you look for. Unsurprisingly, it's going to address those four areas that we talked about. The one thing we really want to focus on, though, and what I think is the linchpin to making this work, is all of the control software, especially in a high mix, low volume, or a very varied manufacturing environment. Having an offline offline robotic programming tool that understands cutting is absolutely critical. So with that, I'm going to hand this over to my colleague, Patrick, and he'll talk a little bit about those tools and what you should look for.
Thanks, Chris. So in order to talk about the benefits of offline programming, I think we first need to look at some of the challenges that come with automation. First off, automating fabrication processes and manufacturing processes have been around for many years, but primarily used in high production scenarios. And initially, things were great. Manufacturers were able to see an increase in repeatability or improvements in repeatability. They were able to meet their increase in production demands, and ultimately the workplace just became, in all, a lot more safer. Then manufacturers started to express interest in automation for high mix, low volume type categories and scenarios. They wanted to take advantage of automation as well, and they did. And one of the first things that they noticed when challenged was the programming methods really made it hard for them to achieve that maximum return on investment they were looking for. They also wanted to automate applications outside of the standard welding application, basic cutting and spraying. They wanted to look at automating plasma cutting applications, polishing, grinding applications. And with that, limited integration resources were available. Integrators that were available, they started to notice that they may not be able to take a one brand solution. So for example, they would implement, say, an ABB robot at one facility, and then notice that for the next application, they may have to go to a Fanuc or a KUKA or a MotoMan for a better fit. So that introduced another challenge. So the first challenge was programming was taking way too long. And the second challenge was robots were already way too hard to program and it required quite a bit of robotic experience. But then to throw on multiple programming languages and multiple controllers on top of that added another degree of complexity. Now, if we look, do we have a poll? No, okay. Now, if we look at the benefits of offline programming, there's a lot of integrators today that are leaning towards offline programming and looking to incorporate offline programming in their automated systems today. Just there's so many benefits to offline programming, but the core four that we see are time savings, improvement in accuracy and repeatability, a reduction of scrap and waste, and as well as an increase in quality. So if I look a little bit deeper, I'd say time saving. So if I take offline programming and I compare it to the use of a teach pendant, to program my robot with a teach pendant, I have to actually take that robot out of production to program or create a program. With offline programming, I can program my robot while it's still in production. The other thing is when I'm using offline programming, I'm able to create or generate a program for hundreds or thousands of points within a matter of clicks, versus a teach pendant where I need to program my robot in a point-by-point manner. Then we look at accuracy and repeatability. So a good offline programming system will allow the programmer to take his or her process knowledge and add that into the software, save it as a proven recipe, and then apply that to the next part and the next part and the next part. Also, a good offline programming system would incorporate a CAD to path approach. So ideally, the programmer would be able to import the CAD model of the part that they want to program and generate paths based off features of that CAD. So again, they're able to generate paths that require hundreds and thousands of points based off the features of the CAD. Then we look at a reduction in scrap. So as I mentioned, a good offline programming solution includes path planning capabilities, but it should also include the ability to simulate the entire process. So as I create my program, I want to make sure I can simulate the process and detect and see if there's any possible costly collisions as well as robotic errors. And then additionally, I want to have a software that has functionality to help me create or come up with efficient solutions to those problems. And then when we look at quality, I think if you look at some of these benefits we've already talked about, some of them, like accuracy and repeatability, of course, automatically result in a better quality part. But that's not all. Like in softwares like Robot Master, for example, what we're doing to advance the software and advance the industry is we're actually taking some of that process knowledge and building it into the software, making it that much more easier for our end users. But also the industry is changing itself. Robotic manufacturers are constantly coming up with and developing new robots to support more robust programming, create more accurate programs, more repeatable. Integrators are increasingly adding new technology like vision, for example, that all cater to an increase in quality. And it's important for the software solution to be able to adapt to that increase in technology and to be able to implement it inside the software so customers can take advantage of that enhancement as well. Next slide. So now you're interested in automation and you don't know where to start. Well, finding the right integrator is a very critical first step. Now today, we do have customers that reach out to us with expressing interest that they want to develop and implement a cell themselves. And ultimately, they're better off searching for an integrator, working with an integrator that's going to save them time, money, and reduce a lot of the risk. Something I definitely noticed myself when I got involved in the industry is every customer is different, whether they're water jet cutting, plasma cutting, or welding. They all have different parts that they need to manufacture, different quality aspects that they need to achieve, and different processes. And it's very important that when you do get in touch with an integrator that you collaborate with them, you communicate with them constantly. And it's much easier to communicate and get things done properly if the integrator understands the application. So it's important to work with an integrator that has experience in that application. And don't be afraid to lean on your network for recommendations as well. So for example, who better to point you in the right direction with interest to a robotic plasma cutting system than getting in touch with your plasma supplier like Hypertherm and saying, you know, Patrick or Chris, who's available in my area? Who can I reach out to investigate a robotic plasma cutting system? Then when you do find that integrator, there's a couple of things that they're going to look at, maybe some questions that are really critical in delivering a successful automated system. So the very first thing is cycle times, production rates. These are some questions that they're going to ask you. What are you expecting? Do you have a production amount that you expect on a monthly or weekly basis? Do you have a cycle time that you're aiming for? How quickly do you want to produce each part? What are your production runs typically? Are they one-offs? Are they low volume in batches of 5, 20, or hundreds? Are there any implementation limitations like floor space? Can it be serviceable? Is the programming easy? Does it have to be easy? And lastly, what's our return on investment, right? How long can we expect? Is it going to be a 1-year process, 6 months, 2 years to see that return on our investment in an automated system? With that, I believe we're going to be showing a demo video of a robotic plasma cutting application and utilizing offline programming. Okay, great. Now, in regards to the possibilities of automation, and if you are looking at automating a process right now, like plasma cutting, great. I think any integrator that you talk to will first tell you, let's start off small. Let's start off with one application, one process. Let's get comfortable with automation. Let's get comfortable with the process and get comfortable with the programming and see some return on our investment. And then after that, I think you'll notice that you open up your mind to some possibilities, or the integrator will also open up your mind to multiple applications that are possible to automating, like welding or water jet cutting or spraying of some sort. So definitely look into it. There's definitely a lot of possibilities there, as long as you get in touch with the right integrator and the right distributor and supplier. With that, I think we have another poll we're going to bring up here.
Yep, the poll is live. So the question is, for those who said they had looked at automating in the past, why didn't you? And you can select all that apply. All right, Patrick, I'm sharing the results, so I'll just read them. We've got 36% of people said it was too expensive when they looked at automating. 32% of people said the application was too complex. 14% said we were not confident we had the skill set, and 36% of people had other reasons.
Well, thanks everyone for participating in that. And from here, I'm going to pass it back to Chris.
All right. Hopefully the PowerPoint is back up. Really interesting results on that poll. Frankly, that sounds very similar to most conversations we have. Here's just a quick case study. I'm a marketing guy, so if you let me do this, I will go on for another hour or two giving you different case studies, but I just wanted to use one. This also goes back to another tank manufacturer. This was a customer in the Southwest US, and they had they had custom work that they created, critical processes, very high-end equipment that was used in chemical manufacture and others. And in cutting that, both the cylinder as well as the heads for those vessels, they were very similar to the earlier problem statement that we laid out. Cutting was a bottleneck, mostly because between manual layout and quality control, they were spending 2 people for 4 hours just doing layout, and then coming back in doing quality control. Then they were cutting with oxy-fuel, another quality check, and this was consuming at minimum 6 hours. This was a massive bottleneck in their system, and it was going to be very expensive to try to parallel path that. Plus, they had skilled labor issues, not being able to have the right people, hire welders to do this stuff that frankly they didn't want to do. Welders want to weld, and they don't want to spend time on some of these other tasks. So one of our partners worked with this customer. They did not have many robotics in their plant. Our partner had robotics expertise as well as plasma expertise, and they installed. It's an HPR 400. It's one of our best-selling products. Good high-definition system. Robot Master. They cut that 6 hours down to 18 minutes. You know, they still had to generate a drawing solid model for the people to do manual layout. That was done within Robot Master, very quick. You saw how quickly Patrick was able to generate a rock solid cut path. And all of that other wasted time was done and reduced down to 18 minutes. This doesn't even talk about the error rate they had, the scrap rate for very expensive pieces of material. So in the end, they were able to pay this off in 70 working days. It was an expensive system, yet the possibilities that it opened up was, you know, I'm used to paybacks in terms of 6 months, a year, 2 years, 2 months, basically, call it 3 months of working days. This customer was able to pay off their system. So not only that, but this unlocked all other kind of value. It pushed the bottleneck somewhere else in their system. And they actually found that the cutting cell was sitting idle. And just like Patrick said, that opened up their mind to, well, hey, what else could we automate? Can we have that cell, that robot, do something else in its downtime? And they're looking at other processes that they can continue to expand. So, you know, the idea of the expense, the complexity of doing it are all valid reasons. What we've been able to see is the expense is justified. And if you have the right tools, that complexity reduces quite a bit. So I guess just kind of summarize what we've been talking about a little bit, and we really are interested in your questions, is when you think about the solution, it needs to think not only robotics, but also plasma. Having a system integrator that understands both and or who can tap into that application knowledge is really vital. Hypertherm's got a very broad set of channel partners that we work with around the world, and we are happy to drive business to them to know how to do that. Your plasma provider hopefully has also worked in robotics and has tailored hardware for a robotic arm, knowing how to do leads management, stresses on the system. We are continuing to work with robot manufacturers to incorporate plasma knowledge in their controller and have those standardized cell designs. And while you know, we're shilling obviously a little bit for the company, having a tool like Robot Master that really not only removes that need to be a robotic expert, but also removes the need to have the art and science understood of plasma cutting is really valuable. So I hope you look into this. We're happy to answer questions now. Contact us later. Talk to your integrator if this is of interest. We're excited about taking on these kind of applications. And thanks a lot for listening. And at this point, I think I'm going to hand it back probably to Clarissa to help us answer some questions.
Thanks, Chris, and thanks, Patrick. We've got a ton of audience questions, so I'll go ahead and get started. So, Patrick, this first question looks like to be for you. Is offline programming, offline programming makes sense to me for large production runs. Is OLP a good fit for high mix, lower volume production?
Absolutely. So you can make a case for offline programming for both high production and high mix, low volume. Now, most of our customers, I would say, fall into the category of high mix, low volume, because that's where you're going to see most of the benefit and return on investment. But I wouldn't limit it to only high mix, low volume. You could take advantage of OLP for large production runs. If you're going to be needing to produce a program maybe once a year, may not be worth it, but you really have to look at the cost of the software, how much you're going to be reliant on the programming, how self-sufficient you want to be on the programming, and do a bit of an analysis from there. But I wouldn't categorize it only for high mix, low volume.
Yeah, and I had the distinct displeasure of having to use a teach pendant once to help program a robot, and that's no fun. Definitely would have liked to have that software.
Thank you. Our next question, Patrick, might be a good fit for you. What kind of code is generated from Robot Master? Is it similar to G code?
So you can say it's similar to G code. What we're producing is robotic joint code. And additionally, what we're producing is the specific robotic code or output for each brand, right? So Fanuc has their own output and code that they support. ABB, Motoman, KUKA, for example, has a couple of different styles of output that they support. And we support and we can generate all of those different languages.
All right, this question goes to either of you. Has this ever been tested in the stone fabrication industry? Granite, marble, quartz?
So we don't have anybody on from our sister division, OMAX, but plasma wouldn't be a good fit for that. It's a perfect fit for water jet. And frankly, there's nothing about it. I'll let Patrick either nod or disagree with me, but there's nothing about the cut path generation that would be only applicable to plasma. It's about us building that knowledge of water jet into Robot Master. Everything else should be the same, though. I don't see a limitation that it couldn't be used for that. And Patrick, I'll let you kind of expand.
Yeah, absolutely. There's been a definite rise in interest for robotic water jet cutting, especially for the use of cutting granite, marble, and quartz.
Composite too, kind of that.
Exactly. Definitely, mostly water jet for that type of material. But we've also worked with integrators that are cutting those materials using a milling spindle, for example, for architectural. And then on the water jet side, more used for like countertops, that sort of thing. But definitely can be done, mostly water jet, and the interest in it is growing rapidly every year.
Thank you. This next question is again for both of you. Do we need to hire a robotic programmer to use Robot Master?
I'll take this one. No, that's sort of what I was trying to point at in my video is now, can you walk into a shop with zero robotic programming expertise or knowledge and grab Robot Master and start programming? Most likely not. We do recommend having some basic knowledge of the teach pendant, how to load a program, that sort of thing. But most of the complex errors and problems that come with programming a robot, things like singularities, joint limitation, wrist flips, those are difficult for a new programmer to grasp and understand how to solve them. And that's where the software comes in. We provide the user with tools to help them solve them quickly and efficiently.
Yeah, I just wanted to throw in, not from personal experience, but seeing others as we have engineers on the hypertherm side that know plasma right, left, up, down, every which way, really weren't robotic experts at all. And their learning curve to become proficient in Robot Master was very, very quick. And these are people that, while they're smart, they're technical, they weren't robotic engineers, and they picked it up pretty quickly. And that we use it in our labs as we do proof of concept cutting, developing other techniques all the time. And that was them coming from a baseline of zero.
Well, thank you. To our audience, we are flying through questions and we've got time to take more, so please keep them coming. These are great. Our next question looks like to be for Patrick. In a single part flow, how does an OLP manage this type of production style?
Yeah, so we see this a lot at Robot Master, single one-offs, single part flow. There's a number of different ways you can approach it. For example, we have customers that produce one specific style of part with certain variations. For example, the dome that you saw in the video, not every single dome that we work with is the exact same size with the exact same hole locations. So with that, what our user does is they take some of that process knowledge that we've built into the software. Sometimes they modify it themselves, and then they take that process knowledge and apply it to the next dome. Now, if the part is completely different, same approach, you'd import your CAD file you would apply your paths using a specific module. So we have modules for cutting purposes, we have modules for spraying, polishing, grinding, and essentially you would select the features of your CAD model. That's what's going to help you generate your path and drive the path, and then from there onto your simulation stage. So same process essentially as you would for high mix, low volume or high production.
Yeah, and I've seen specifically, we see just a ton of automation going on in China, especially. There's just two customers that stand out. Well, I'm going to get the numbers not exactly right, but they're notionally correct. But we've got one customer that they have 4,000 different parts that go through their robotic cutting area, 4,000 different variations. They've done all that programming at some other point, and they've got a library of those cut paths, and then the part comes up, and we've seen some that use imaging to identify what the part is, or read a barcode and go and it goes and grabs that set of code, and then goes ahead and cuts the system. So that's how they're dealing with that. I mean, that's almost the ultimate of high mix, low volume, where every part coming down the path is completely different from the last.
Thank you, guys. That looks to be like our last question. So thank you for taking your time to present this content to us and answer all of our audience questions. It was great to have you today.
You bet.
Thanks, everyone.
And
Take care.
I think
we have our next webinar coming up this Tuesday, which is deploying cobots to fill your manufacturing needs. So you can learn more and register for free at automate.org/webinars. I hope you found this webinar to be interesting and informative today. If you have any questions about A3 or the webinar today, please reach out to myself or Robot Master, and I'll give you my email in the email that we'll be sending out tomorrow with the recording of this webinar. Thanks again to Chris and Patrick for a great presentation, Robot Master for your sponsorship, and to all of our listeners for your support. Stay safe and healthy and have a wonderful rest of your day. Thank you.